If we delete the limits, the most enthralling divine body I perceive is the one that may be phenomenal in our sky. It is this one bug squeeze. It's an enormous, red, very Goliath star, and in the event that you were to situate it where our sun is, it would stretch out completely to the circle of Jupiter. This gigantic, very unsteady, and nearly detonating star is not as direct as it may appear to be in the universe. These titanic events, like the most extreme supernovae, could shake all that we notice and even things we don't. However, we can't see it obviously. Betelgeuse is thought of as an image of a red, very Goliath star, commonly much larger than our own sun. Brian Cox, along with other astronomers, believes it could detonate in a cosmic explosion soon. People have grown increasingly concerned about what will happen since the James Webb Space Telescope has been capturing astounding images of the star. When exactly will Betelgeuse eject into a cosmic explosion, and how critical will the impact be on the planet? We should dig into a star in the Grand Orion constellation, which shines so brightly that even ancient civilizations noticed it. The impressive star Betelgeuse dwells on the eastern shoulder of the Orion constellation. It ranks as the second-largest star in Orion, and its name comes from this location, marking it as a shoulder star. Betelgeuse is likely one of the brightest stars visible in the night sky. Despite its brightness, the star emits a surprising red shade, which, as we will investigate, signals possible danger. Humankind has long studied Scarab Jew. Greek astronomer Tmy noticed it long ago. Back then, the first thing people recognized about stars was their color. Tmy noted that the star appeared with a reddish-orange tint, a disturbing sign. Recently, scientists have been studying the star with even more precision, and they now have a much clearer understanding of what makes it so strikingly luminous. One of these factors is that the star undergoes significant variations in brightness, fluctuating by as much as 0.6. Betelgeuse is a variable star, meaning its brightness changes periodically. In 2019, researchers discovered some new behaviors of the star that had never been seen before. Despite the fact that Betelgeuse didn't stop shining completely, its luminosity significantly decreased. It darkened to a degree of around 1.6, prompting researchers to investigate why such an anomaly was occurring in one of the brightest stars in the sky. They were hoping to find an explanation for why Betelgeuse was acting so unpredictably. According to their findings, Betelgeuse could explode as a supernova at any moment. Brian Cox, a renowned scientist, shared this concerning evaluation. As a distinguished professor of particle physics at the University of Manchester and the Royal Society's professor for public engagement with science, his opinion carries weight. He also presents popular science TV shows and writes books, making his perspective highly regarded. Brian Cox explained that Betelgeuse seems like a ticking time bomb, one that could erupt with almost no warning. To support this claim, the James Webb Space Telescope has provided significant evidence. However, some peculiarities about Betelgeuse have raised many questions. Why does Scarab Jew behave so strangely in terms of its variability? With new data, Betelgeuse has earned its place as a candidate for a supernova. However, researchers still don't know when the explosion will happen. The fact that Betelgeuse's mass is nearly twice that of the Sun supports this prediction. Generally, stars with at least a few times the Sun's mass are considered potential supernova candidates. The plot thickens, though, because scientists have used various tools to investigate Betelgeuse, such as the James Webb Space Telescope and the Laser Interferometer Gravitational Wave Observatory, to uncover the star's mysteries. What they've discovered remains shrouded in mystery. Betelgeuse was born on August 31st, a very long time ago. Since then, the star has been displaying strange signals that keep its future uncertain. What did they find? They detected unusual light waves emanating from the star, raising further interest. But this wasn't the only strange occurrence. It takes us back to the fact that Scarab Jew is a variable star, fluctuating in brightness. There were reports that Betelgeuse had regular dimming episodes similar to sunspots on our own sun, but the cycles were different. It shifts between bright and faint phases twice as fast as it once did, another odd sign that Betelgeuse is acting strangely. In February 2021, researchers observed that the star's dimming cycle reached a brightness band of +1.61. This was shortly after the star had experienced a significant dimming event, marking the start of its unusual behavior and raising alarms that Betelgeuse may be nearing its end. The drastic dimming between 2019 and 2020, reaching its lowest level, led many specialists to believe that the star would explode within the next 100,000 years. However, when Scarab Juice brightened once more after this extraordinary dimming event, things became even more baffling. Astrophysicist Andrea Dupree, from the Harvard-Smithsonian Center for Astrophysics, observed that the star was now 150% brighter than usual, making it the seventh brightest star in the sky. Scientists were stunned to see a red glow emerging from the southern part of the sky. What is going on? The situation became even more astonishing. This development sparked various theories about the cause of Betelgeuse's extreme dimming. It's essential to highlight that not every star emits the same red glow that Scarab Juice does. This glow marks Bug Juice as a red supergiant star, which is the last stage of a star's life before its death. This red hue is the result of a surface temperature of around 3,500 Kelvin, significantly cooler than the outer layer of the Sun, which is near 5,500 Kelvin. Since Scarab Juice is cooler than the Sun, it emits less energy per unit of surface area, even though it is much larger and on the verge of exploding. We should also consider the exceptional dimming event. Brian Cox raises the question, does it really mean Betelgeuse will go supernova? The fact that Scarab Juice is already in its red supergiant stage indicates that it is approaching the end of its life as a star. A star in this stage often dims as it dies, and this is something scientists can detect. However, Betelgeuse's recent bizarre behavior has led researchers to focus even more on monitoring it. Today, multiple telescopes are focused on this mysterious dimming event, trying to gather more insights. Things continue to get even more intriguing, as scientists still don't have a deep understanding of Betelgeuse's behavior. Using cutting-edge instruments, researchers are closely observing the star. The James Webb Space Telescope has been one of the most valuable tools since its launch in 2021, helping astronomers gather new, crucial data about Betelgeuse. The telescope's images of the star's remarkable dimming have shown that the event caused a massive mass ejection, about 400 billion times larger than a typical coronal mass ejection. Researchers remain captivated by the ongoing mysteries of Betelgeuse, carefully monitoring every fluctuation in brightness and every unusual pattern in its behavior. Advanced observatories across the world and in space continue gathering data, seeking answers to questions that could redefine our understanding of stellar evolution. Despite its unpredictable nature, one certainty remains. When the time finally comes, Betelgeuse's supernova will be one of the most spectacular events ever witnessed by humankind. Astronomers predict that when the star ultimately explodes, it will shine brighter than a full moon, casting a glow visible even during the day. The sudden, immense burst of energy will send shockwaves rippling across space, dispersing heavy elements crucial for forming new stars, planets, and potentially life. While this event will be breathtaking from Earth, scientists reassure that it poses no immediate threat to our planet due to Betelgeuse's distance of over 600 light-years. The study of massive stars like Betelgeuse not only provides insights into their lifespans but also helps refine models of how galaxies evolve. Each star that reaches the end of its life in such a dramatic fashion contributes to the endless cycle of cosmic transformation. When Betelgeuse's supernova finally occurs, it will mark the end of a celestial giant, but at the same time, it will pave the way for the birth of new cosmic structures. For now, the universe keeps its secrets, and humanity watches and waits. With every new discovery, our understanding of the cosmos deepens, reminding us of both the fragility and grandeur of existence. Until the moment arrives when Betelgeuse lights up the sky in one final, breathtaking display, it remains a beacon of curiosity, a reminder that even the most titanic celestial bodies must one day succumb to the ever-turning wheel of time. As scientists continue to study Betelgeuse, their observations grow more precise, fueled by increasingly sophisticated technology. Space telescopes like the James Webb and Hubble have provided invaluable data, allowing astronomers to track the star's erratic dimming and brightening cycles with unparalleled detail. Every shift in its luminosity, every strange fluctuation, adds another piece to the puzzle of its impending fate. Despite the uncertainties surrounding the exact timing of its explosion, one thing remains clear: when Betelgeuse does finally go supernova, it will be one of the most significant astronomical events of the modern era. The blast will not only illuminate the night sky but also provide a rare opportunity for scientists to observe and analyze the intricate processes behind a star's final moments. Unlike past supernovae, which were often detected only after the explosion had already occurred, Betelgeuse's transformation is being anticipated in real time, allowing researchers to collect critical data before, during, and after the event. This wealth of information will deepen our understanding of stellar evolution, shedding light on how massive stars die and what happens in the aftermath of such a cataclysmic event. The explosion will scatter heavy elements like carbon, oxygen, and iron into space, seeding the cosmos with the building blocks of future stars and planets. In this way, Betelgeuse's death will not signify an end, but a beginning, the continuation of the eternal cycle that has shaped the universe for billions of years. Meanwhile, astronomers remain vigilant, scanning the skies and refining their predictions, eager for any signs that might herald the impending explosion. Whether it happens tomorrow, a century from now, or even farther into the future, the day Betelgeuse erupts will be a moment of wonder, discovery, and cosmic transformation. Until then, the star continues its slow, unpredictable dance in the night sky, an ancient giant awaiting its final, brilliant act.